All right. Hi, everyone. Hello. Hi. Have you forgotten how to say hi? Hello. Hi, everyone. Yeah, I guess you guys aren't necessarily feeling up to it right now, but please, let's say hi. Hi. Hello. Hey, back there. Hi. Hello. All right. How are y'all feeling? Yeah. All right. Well, the midterm happened. In lab and discussion today and tomorrow, your TAs will also discuss how to interpret your score, what you can do to improve. And as instructors, we've also come up with a couple of things that will help you improve your score. So don't worry, hope is not gone. You still have a chance. You still have opportunities to improve. And we want to make sure that you feel empowered to do so. So we have a couple of things planned, not exactly like 100% finalized yet, but we should be able to send some more information to you like maybe later today. All right, so about that, we move on. Today we're talking about objects. But before we get started, let's talk about some announcements. So here we go. Homework 6 is released, and it's due this Friday. The ANTS project is released, and it's due next Tuesday, July 25th. This is a partner project, so that means your TAs will help you find a partner if you don't have one already, or you can also just go ahead and ask like one of your previous lab partners to work with you. Maybe you can choose someone that you particularly liked working with. In addition, Hog composition regrades are available, so you can go ahead and revise your work and submit by Sunday, and you'll get your 2 out of 2 points, and you'll be all done with Hog. Midterm scores are released on Gradescope. Boo. After lecture, submit a regrade request, and you have until Thursday night to do so. So this is the redemption opportunity I was mentioning earlier. So we'll be giving out some kind of redemption opportunity. Again, details aren't entirely finalized yet, but I think we'll give about maybe a maximum of 6 more points towards your midterm if you complete all of the required parts. So the current plan, I think, is kind of like a sneak peek, is we'll be doing like some part is going to be like a redemption quiz that you might do in discussion later this week. That's like worth some part of the points. Another part is going to be like a midterm checkoff, kind of similar to what you do in lab with lab checkoff. You talk to someone, go over like how you felt, how you can improve for next time, what were some of the missing strategies. So the idea here is we want you to improve, learn from your mistakes, and to kind of reward you, we'll give you like a little incentive to do so. More details will be coming on Piazza later. And in addition, we also have additional extra credit opportunities later. So you'll notice with the ANTS project that'll be released today, not only do you get 1 extra credit point for submitting early, like you have been getting for the past previous 2 projects, but there's also going to be an extra credit part of the project that's worth an additional 2 points. So historically in CS61A, we like to give out lots of extra credit, maybe around 10 or so points per semester. So far, we've only given out 2 points. So you can look forward to maybe like 8 or more points of extra credit later in the semester. Any questions about announcements, about what we're going to do? Some of these announcements are a little vague because we haven't quite figured it all out yet. Yeah, Sudambi. So ANTS will be released as soon as Stan is done reviewing it. Just one last pass. So probably after lecture sometime in the afternoon, hopefully. But latest probably tonight. Yeah. And if we end up pushing it back, we'll give you more time naturally. Any other questions? Comments, concerns? As always, you can always give us either email us directly if you're concerned about the midterm, email your TA, email your mentor, tutor, whatever. They're all here to help support you in this time of need. Okay. So this week we're talking about objects. And the goals are to learn the paradigms of object-oriented programming. We also call this OOP, O-O-P. And we'll study the applications of and the problems that can be solved using this paradigm. So last week we learned a little bit about non-local with mutation. And so this week is kind of an extension of that idea. What can you do with what we call state, when your program remembers information about the world? So object-oriented programming. First of all, let's do a little quick review of data abstraction. So remember, data abstraction lets us treat compound values as units. So we have how compound values are manipulated. We talk about it in terms of their behaviors, what they can do, and how compound values are represented, how we actually program or implement that data. We mentioned that there's an abstraction barrier, and the way you cross that abstraction barrier is using constructors and selectors. Remember, for example, that we use constructors like making a mobile, and I can select the weight from a mobile or the end of a mobile. So those are constructors and selectors. OOP has these same components, this idea of structure and a selector as well. We just have a very special syntax for making them. So Python just wants to help simplify your life. And so we're teaching you OOP because that's a way that's very commonly used in industry to do so. So object-oriented programming. It's a method for organizing programs through what we call objects. So we've kind of mentioned this term a little bit earlier as well when we talked about functions and lists, but now we'll formally define it. So objects have attributes, which is how they represent, which is part of the representation, what information they carry. So for example, if you think about linked lists have a first and a rest, two attributes. And we'll see that the object version has those two attributes as well. Objects can interact with each other. They have well-defined behavior. And for example, with the linked list example, I can select the rest to move on to the rest of the linked list. That's a type of behavior. It's very simple behavior, but it is a type of behavior. And object-oriented programming is a metaphor for computation using distributed state. So one of the things we realized earlier with creating linked lists, with creating lists, with creating trees, was that we could have multiple of those things going on at the same time. I can have more than one list in existence, and they all have different values in them, right? And they all somehow keep track of those different values. So objects are the same idea, just more general. We have different objects that contain some information within them, but that information might differ from object to object. Like I'm a human, I'm different from Stan, I'm different from Yichen, I'm different from Annie, I'm different from Kelly. Oh, by the way, we should give those few people applause because they're always here at lecture. So can we give a moment? Applaud them for their piazza help. Yeah, so for always being on lecture, live lecture threads. Thank you so much. So object attributes determine their local state. So I was mentioning earlier, like a list might know about its values in that list. Object interactions are provided by methods. So methods is like a fancy name for a function. We'll learn more about the exact differences between them, but for now you can think of methods as being the same as functions. Objects are organized under a system of types. For example, I know that a linked list is different from a tree, and that distinction is important because they have different representations and different behaviors. So Ramvi, do you have a question?
So kind of going back to, for instance, the metaphor for computation is a distributed state. Do you explain what it means by distributed state?
So Sudambi's question was, what do we mean by distributed state? So distributed state means that we just have different objects coexisting at the same time. Like I can have an object that represents me, a human, Kevin. But this Kevin is separate from Stan, who's also another object who exists in the same program, but we have different state. I think so. Like for example, I might have a different amount of money. Okay, maybe that's a bad example. I might have a different, this is a balanced example, that's why. I might have a different amount of money, or I feel like I would just say mean things about Stan at this point. But the idea is that we have different attributes. Like my name is Kevin, his name is Stan, right? So we can have these different attributes about ourselves, and we're distinct objects. So that's this idea of distributed state. We have individual objects with their own state. Does that clarify? All right. And different types may relate to each other. So this is an idea that we'll explore more in detail tomorrow about how types can relate to each other. But for today, just kind of an introduction to typing. All right, classes. So every object is an instance of a class. And the way I want you to think about it is like, it's kind of like a template. The class is a template. I was mentioning this earlier, but Kevin and Stan are two humans. This idea of us being part of the same kind of like species, right? You can think of that like a class. Like we're both humans. We're not both dogs or cats, I think. So a class is a type or a category of objects. And a class serves as a blueprint for its instances. Like, for example, I was mentioning this earlier, but I have a name, Stan has a name. So that's part of our blueprint. But the values for our names might be different. So Kevin is a human. Kevin is the instance. I am a single object. I'm a single instance. And the human is the class. It defines what I am. So Kevin has a name and an age, and these we call attributes. So I have a name, I have an age, I have a certain amount of money, I go to UC Berkeley. So these are all attributes of Kevin. These are all features that I have, part of my representation. Kevin can talk to other humans. So this is an interesting point because it defines a behavior. So notice that behaviors, you can kind of think of them as like actions. Like I can talk to someone else, I can trade, I can learn from others, stuff like that. So are there any questions about classes or objects that I've covered so far? These basic definitions, start to feel a little comfortable with them. All right, let's move on. Let's talk about the class statement. So this is how Python implements this idea of a class. So we have a class definition that looks like this. This is the syntax. It starts with kind of like how def looks, right? DEF, except now it's class. So I have a class, I give it a name, and then inside I tell it what to do. So when I execute the statement, I create a new frame and execute the suite of statements. So usually that suite of statements just includes assignment statements for those attributes and def statements for the behaviors. So I create a new class with the bindings from the frame. I bind the class to name in the original frame where it was defined. So for example, I might write this code in the global frame. And when I say class human, and then in the suite, I might put name and age. Now I have a human in the global frame. So as a different example, we have a class of clowns. And if you look at the definition for that class of clowns, I have that it has an attribute for the nose, which we define as being the color red. And it also has a behavior that we give it using a function or a method. And that function is the dance function. So if we take a look at this more in depth, what happens is if I define this in the global frame, what will occur is I execute the class statement, which creates the beginnings of a clown class. And when I go through line by line, I execute each line of that suite and bind it to the clown class. So I have a nose, which is red, a dance, which points to the function that tells it how to dance. And then once I've finished executing all the lines in the suite, then I rebind it to the global frame. So now I have clown, which refers to the class of clowns. Questions about this diagram? Do you want me to replay something? Yeah, back there.
Is nose an attribute or a state?
Yeah, great question. What's your name?
Henry?
So Henry asked, is nose an attribute or a state? Is that the question?
Yeah.
Attribute or state. So I think those are kind of intertwined. So we say attributes like nose help define the state of an object. So in this case, notice that it's defined in the clown class. So we'll get into this a little bit more, but all clowns have a nose, which is red. So that's the state that you should be worried about right now. So state means this is like what an object has right now. And right now, we're just saying the class of clowns has a red nose. So we'll touch on more on that later. Yes?
So is this a new frame for the clown class? Like if you were to the virus diagram, would that be a new frame?
Great question. What's your name?
Talia?
So Kalia asked, would that be a new frame, this box here? So the way this is interpreted is that we execute this suite of statements in a new frame, but we're not actually, like, for example, going to draw that on an environment diagram. Like the suite of statements is executed on its own, and then it's bound within this thing, which we'll call an object itself. So there's some details here underneath it, but I just want you to think of this diagram as a representation of what the clown class has. Yeah, so it's not actually a new frame once it's created, but all the statements inside of it are executed in a new frame. Any other questions? These are good clarifying points. All right, so then now if I think about how my lookup procedure works, I can ask for clown.nose. So we've seen this dot notation a little bit before with lists, but now I can do it with my own objects too. So if I look up clown in the global frame, points to the clown class, then I can look up the nose attribute. And then it evaluates to red. So pretty straightforward. I can do the same with the dance. So I look up clown.dance, and clown.dance evaluates the function dance. That takes in no arguments. So when I call it, I should then get no thanks. All right, and then if I ask for what clown is, Python defines clown itself. Notice that I drew it as a clown class. It'll say, I found this class of clowns. So this is how Python represents the class object here. All right. So then if I look at a more similar example to what Stan showed in last lecture, the account class we can define as being this idea that all bank accounts have a balance and an account holder. So these are two features, two attributes that all bank accounts have. And the account class should add attributes to each instance. This is something we want out of this account behavior. So if I look at the behavior that I would like to happen, is I'd like this code to all work. So I'd like to be able to create an account for Kevin. I'd like to say that my holder, the name of the holder is myself. I'd like to be able to have a balance of 0. And I'd like for all bank accounts to be able to withdraw and deposit in the same way. So I'd like to be able to add money or remove money from this bank account. I can say a.deposit 15, which should return 15. And now if I try to withdraw money, it should remember the fact that I added 15, and now I'm trying to withdraw 10. So this is kind of like the key point that links it to last lecture, was that we had this same behavior where I could add money, add $15, somehow remember that fact, and then withdraw $10 later. And then my balance should still reflect that information. I should still only have $5 left. So then if I try to withdraw 10 more, I should say I don't have enough money or insufficient funds. So this is the behavior we'd like to see from our class, and then we'll show you a little bit later how to program that. But one more idea we want to show you. All bank accounts share a withdraw and deposit method. So we'd like to save a little bit of code writing and have all bank accounts use the same underlying code. So this is the idea that we're exploring today, is how we can use objects, class statements, for example, to create objects that can do that without having to write the same code over and over again for each different object. And the way we can do that is through this. All bank accounts have a balance and a holder, and the way we can define that is by creating a new account class. So there's this new feature here I want to point out, def init. So this is like a fancy looking thing. You have to type it with underscore, underscore, init, underscore, underscore, exactly like that. You need to give it something called self and something called name. I'll explain more about what that does later. But here are the two features. This is when I tell it what my balance is. Self.balance, my own balance, is 0. And self.holder is going to be the name that's passed in. So if I try to create an account for Kevin, what will happen in the environment diagram, if you want to try to visualize it, is this. So when a class is called, a new instance of that class is created. And the init method of the class is called with the new object as its first argument along with remaining arguments. That's a kind of a mouthful. I'll show you what it means. So here, I am creating the account for Kevin. So I make a new account class, a new account object. I pass in self. Notice this is the account object where self is passed in. And Kevin, the string for the name, is going to be the first argument. So this self is like automatically passed in when I make an object. So here I'm making an object. So I pass in Kevin for name. And now when I say self.balance, the assignment just kind of works out. Because I look up what self is that account object. And now when I try to assign the name balance to it, I can just put balance in the bindings. And same with self.holder being Kevin, I can just put that binding right into the account object as well. And finally, I can then bind it to the name A to complete the assignment. So all the work earlier was to create the account object, and this very last step was binding it to A. Yeah, Martin, right?
Yeah.
Awesome.
How is the class different from, say, abstract data types?
Yeah, so Martin's question was, how are classes different from abstract data types? And abstract data types, remember, we kind of implemented them like, for example, with linked lists, we implemented them with lists, for example, underneath. And we had to define constructors and selectors. So some of those things are still the same. We defined a constructor, this is called a constructor, the init method, for the account class, but now we don't have to rely on putting everything into a list or putting everything into a dictionary. It's like we had that additional step of figuring out, I want to put this here, I want to put this here, I have to index into this, I have to select this value, right? That seems kind of painful. So Python built this in to make it easier. So you don't have to worry about, is this going to be a list? Is this going to be a dictionary? I can instead worry about what its attributes are. Does that clear things up? Yeah. So going forward, you'll find that these are a lot more useful than ADTs, but they're the same underlying idea. Any other questions? Clarifications? All right, so now if I ask for a.balance, I can just look up balance in the object A, and that's 0. Same way I can do holder, I can just look up in the object A, holder is Kevin. And so object instantiation continued. Every object that is an instance of a user-defined class has a unique identity. So we also touched on this last week a little bit with mutation. But if I create 2 different accounts, this is where stuff is starting to get useful. I can make an account for Kevin, that's A, an account for Stan, that's B. So every call to account creates a new account instance. So imagine that previous picture we had of account object here, but now we have 2 different account objects. So I have one for Kevin and one for Stan. And this is how we keep track of who's who. So if I ask for a.holder, I'll look up in Kevin's object and return Kevin. B.holder should be Stan. And this is kind of the point that we saw earlier. We can use the identity operators is and is not to test if 2 expressions evaluate to the same object. So we should see if I ask, is A, A? So A is A, Kevin's account is Kevin's account. Yes, so they're the same object. So that should return true. And A is not B. This is asking, is Kevin's account distinct from Stan's account? And that should also be true. Binding an object to a new name using assignment does not create a new object. So this has like similar behavior to what we saw with lists and functions, where when I make an assignment like C equals A, I just copy over the pointer, right? Copy over the arrow. So now C will point to the same account as Kevin. So now if I ask, C is A, well, they both refer to the same Kevin account, the exact same Kevin account. So it's true. Questions about all this material? Do you want me to show you something? Any questions, clarifications? All right, cool. Early break. Really early break. Going really fast today. What's up? Hey, hey, hey. While we're still in break mode, I want to say one thing I'm really disappointed about from the midterm. I don't care about your score. I'm really disappointed that you didn't all cooperate. That is sad. That is really, really sad. I wanted to give you all one extra credit point. What are you doing? Cooperate. We'll try again next time. Cooperate this time.
say it at the end of the break. So like, whatever you say.
I'm done. I'm done with
Are you
it.
done?
Yeah.
All right.
Turn it on.
Turn it off.
Yeah.
Awkward. But no, it's just dead.
Yeah, you're
We're
good.
dying.
No, you're good. You're good. You're good. Yeah.
All right. So yeah, I'm super salty about the extra credit problem. Hey, break is officially over after this. So yeah, I'm honestly probably the most salty person on the staff about this problem because I kind of want to give you all 3 points. So next time, I think you guys should cooperate.
Yeah.
Back to Kevin.
All right. Back to business. All right. Oh, what was your name again? Ah, I forgot. Talia. Yes, go for it. That's a secret. I don't want you to play number games and think about it again. Yeah. After we play the next game, maybe I'll tell you. Other questions that don't relate to the cooperation game. Yeah.
Has that cooperation game ever been done before? Yeah, like the business one has never been done before.
Yeah, what's your name?
Drew. Has anyone ever cooperated?
Drew. So Drew asked, have we cooperated before? This is a cooperation game question. I should not answer this. But I think they did it last summer, right? Where they said everyone, 100%. But like, no, I don't think that's reasonable. Yeah, they tried it last semester with 100%. I don't think it happened either. Yeah. So this time we'll be mixing things up, and then hopefully you'll cooperate now. Forced cooperation. I like it. Yeah. Sorry, louder. So what was your name? Matthew? Joshua asked, what happens if you leave it blank? I just don't count you. All right, so attributes. Dot expression. So we saw a little bit of this earlier. A dot expression looks like this. I have some kind of expression, then followed by a dot, and then I have some kind of name. So it's pretty straightforward. Dot notation accesses attributes of an instance or its class. Expression can be any valid Python expression. I think this is a slightly tricky part, though, because the expression over here before the dot can also be a dot expression. So you could have multiple dot expressions followed by each other. So the dot expression evaluation rule looks like this. Evaluate the expression to the left of the dot, which yields the object of the dot expression. Then return the value of name from the instance attributes. So here's the tricky part. This value of the name might also be another object. So you can put it in another dot expression. If name cannot be found in the object, we can look in its class. So, for example, if I say a.deposit, I will look up in A, I'm going to try to look for the name deposit. And then once I've found the deposit method of account A, then I can call it with the parentheses and give it the argument 100. Class attributes are shared across all instances of a class. They are attributes of the class and not of any one instance. And because of evaluation rules, we can look up class attributes through instances. So as an example, I can create my account class, and now all accounts have, surprise, an interest. So I have an interest rate of 0.02, which is pretty generous, honestly, these days. So I can ask for what is the account's interest, the interest across all accounts, and that's 0.02. So now if I make my own account, though, and make one for Stan, if I ask for my account interest and Stan's account interest, right now they're all the standard 0.02% interest rate. But I can change the account's overall interest to 0.01. And now, because of the evaluation rules, what should happen? They should both be 0.01. So now universally, if we change it in the account class, and because the evaluation is going to the account class, they'll both see the change. So there's going to be some additional complexity we can add on here. So let me show you a quick demo of what we can do. So I've loaded up the Python file containing the account class. I can go ahead and ask for account.interest. Well, let me increase the size a little bit. Yeah, make it big, really big. Okay, account.interest is 0.02. I can make an account for Kevin, make an account for, oh gosh, account for Stan. And then now that I have both of these accounts, remember we can still do stuff like I can look up, my name is Kevin, I can look up B's account is for Stan, and we can do the same thing where we saw earlier where I can do A.interest and B.interest. And they should both be the current account rate of 0.02. The one interesting bit is that I can also do stuff where I can change kind of the interest rate just for me. Maybe I want like a high interest rate, 0.1. Ooh, making big bucks. All right, so now if I ask for my interest rate and Stan's interest rate, what's happened here? Think about it in your head. How does the diagram change? Why does this occur? And the next question will be, what does this value to? So spend a minute or so thinking on your own, talk to people around you. What happened? How does the diagram change here? And then try to answer this next question. All right, what should account.interest print? What should display here? What should display here? Shout it out. 0.02. Brave soul. So if you think about the way this plays out, what did I actually assign here? A.interest equals 0.1. Did I assign it to Stan's account, my account, or the class of accounts? That's the question we want to ask ourselves. Because we look at the evaluation, right? A.interest is going to be referring to A, which is Kevin's account. And now, since it's an assignment statement, I'm assigning the interest attribute of Kevin's account. So if you think about it, Kevin's account previously only had balance and holder, right? Balance and holder was all it had. But now we're adding an interest attribute to Kevin's account. So when I look up A.interest, A.interest will find interest in Kevin's account, and it doesn't have to look up in the class. So that's what's going on here. B.interest is still the same as account.interest. Sudambi.
So can you add any kind of attribute using that dot notation?
Yeah, so Sudambi's question was, can I add any attribute using the dot notation? And yes, this is like maybe a huge difference from if you've done like Java or other more structured languages, is that I can add anything I want to anything even after I make the object. I can change things up, I can modify it, because all of these things they're just bindings. I can rebind them, I can reassign them. Yeah. Cool. All right. So we saw how we can change individual attributes for objects and for classes. So the way we access attributes is I can use a couple of different ways that we haven't quite seen before. So before we saw that I can say A.interest and get the interest for account A, right? Now I want to show you a way we can do it what we call programmatically. So we saw earlier that A.interest only works if I know what I want to get, right? I want to get interest. And as a programmer, I have to know that ahead of time in order for my code to work. But what if I want, for example, more dynamic behavior? What if I want the user to be able to say what they want to get? Maybe they want to get it from the checking account or from the savings account or from some other different area, right? So this is how we can add more dynamic behavior using getAttr. So I can look it up using a string. So I can get the attribute for A's what we call balance using this notation. And it's the same as saying A.balance, except now anyone can pass in a string. I can say I want to get the balance. Or the user can say they want to get the holder, or they want to get the interest. So the key difference here is that I don't need to know ahead of time what I want to get. Now my program can decide for itself. And you'll find that this is really helpful on, I believe, either the homework, I think it's the homework, where you have Miss Manners. So remember that. A.deposit is equivalent to getAttr for A, comma, string deposit. And we can compose these together. Because when I call getAttr of A.deposit, that evaluates to the function for A.deposit. So I can call it with the argument 100. And I also have a function called hasAttribute, which can check if an object has an attribute with that name. So if I just want to check that it exists instead of trying to get it, I can use hasAttr to check if it does exist. And I can also look up an attribute name. Looking up an attribute name in an object may return one of its instance attributes or one of the attributes of its class. So this is similar to what we saw with the dot expressions, where I try to look up in the instance first. If I can't find it, I look it up in the class. Questions about this? Did I make it clear why we care about this? I think that's the big thing. It's like we have these two notations that have the same effect, but we use them in different places. I want to make that really clear to you. Yeah.
If you call getAttribute with a string that doesn't match an attribute in the class, will it make a new attribute matching that string, or will it just give an error?
Great question. What's your name?
Seth.
So Zeph asks, what happens when I try to getAttr for something that doesn't already exist in the object or the class, right? So then what will happen is it won't create something new. It should give you an error.
Then dot notation will also give an error. So why are they different?
Yeah, it's a great question. What's your name again?
Yay.
So Yay asked, dot notation will also give us an error if I try to look up something that doesn't exist, right? So why do any of this? Well, I think the big thing is here. Is that your question, first of all?
Yeah.
So why do we care about getAttr and hasAttr? So the difference is that here, as a programmer, I have to know that I want to look up the balance and type that in, BALANCE, into the code. But here, in getAttr, the user can pass in a string. For example, if I'm trying to write like some kind of ATM machine, I feel like this is the metaphor we're going for here. The user might be able to say, hey, I want to get the balance. So I can ask for balance, and then that will be a string that can be passed in. And then Python will look up for that string. So I think it'll be more clear when you work on homework, the homework problem for Miss Manners, and you'll see an application of where this is useful. If I want to be able to decide, not right now as I'm programming, but later in the future when someone's trying to use the program, what they want to look up. It's really vague, but does that address your question? Not really sure.
The difference is that you can pass a name into that function.
Yeah.
Whereas you cannot pass a name.
Yes, kind of. Yes. So the difference is that here, balance, I have to know I want to get the balance. And it's set in stone. I can't change that code once I've typed it in and saved it. But here, I can pass in anything I want later on. Like, for example, let's say I've written some code and my company is trying to use it, right? And if I've written code using this, I need to save the file and ship it off to the company again for them to use it again if I want to change something, right? But if I use getAttr, the company can pass in a string that they want to use on their own or any object that they want. It's a very subtle distinction I think you won't get until maybe later. But there's this idea that there's a difference between code, which lives in a different world from data. Code versus data. I wouldn't worry too much about it. You'll see an application of this in Miss Manners. Yeah.
Would using the first one break the abstraction barrier?
Yeah, great question. What's your name? Yeah, so Maher asked, is there a problem with abstraction barriers in the first one? I'd say that they're both valid ways of accessing the object. You just use them in different places. when you know what you want to access every single time, and when you don't know what you want to access, if you want the user who's using your program to decide. So you'll see an application of this in Miss Manners, so just chill for a while. Any other questions? All right, demo. So if I try a new demo, I can, as an example, let's say I make an account for Kevin, and I can say a.deposit 100, and now I have $100 in my account. Pretty cool. I can check for my balance, and that's still 100 because I started with 0 and deposited 100. I can check pass adder of balance. And I do have an attribute for balance. I can check if I have an attribute for, pass adder of a comma ecnalab, which I don't have, right? I can get the attribute for balance by typing in the string balance, and I'll get the same attribute I saw earlier. And I can also do the example with depositing. So I can deposit $100 using getAttr like that. So I guess the useful part is I want to show you maybe like a short demo of why you might care. Is like maybe if I want to say I have like a list of different actions I want to do. Like maybe I want to deposit, then withdraw in that sequence. So I can loop over for each action in deposit and withdraw. I can do something like, I can say getAttr of A. Let's run that action and let's pass it in a certain amount of money. This is where I can do some more programmatic stuff. And now you'll see it did both of those actions using a for loop. So the interesting part here is that I can change up my list of actions however I want without having to tie it into my code itself. Like I don't have to type this in explicitly into the code. I can have someone else tell me what they want to do. To me, that's an application of this. So it's like a kind of a trivial example. It's not very useful because I just deposit then withdraw, but I hope it gives you some intuition for why this is like a little bit different from just saying a.deposit or a.withdraw. Yeah.
So like under the hood, is this just like first argument dot second argument, and then it returns that?
Yeah. So there's some details to how Python does all of this. And what was your name again?
Tristan?
Yeah. So Tristan's question was, under the hood, does this really just do a.deposit? Yes, something like that. Yes. You can think of them as basically equivalent. They follow the same lookup procedure, if that makes sense. Yeah. So there's some details to how Python does this, but we won't cover it in class. You can come talk to me in office hours later. All right. So assigning attributes, I can change the attributes for the object of that dot expression. And then if the object is an instance, then assignment sets an instance attribute. If the object is a class, then assignment assigns a class attribute. So we saw this earlier when I tried to assign to a.interest and made it point 1, right? So if I have a class of accounts, I can create an account for Kevin. My interest is 0.02 because I follow the lookup rule and look in the class. But now if I change my interest, then no longer will it evaluate to the class attribute. It will now evaluate to the instance attribute for A. So if I ask for a.interest, because I've assigned it to the object A, then a.interest is 0.08. I can ask for account's interest, and it's simply because a separate object in space, the account class still has a 0.02 interest. And methods. So we mentioned earlier that methods are kind of like functions, but here's the distinction. Methods are functions that are defined in the suite of a class statement. So that's where they occur. These def statements create function objects, as always, like we've seen before, but their names are bound as attributes of the class. So if I define it in the class account, an init method, which is the constructor, a deposit method, which lets us interact with this object, and a withdraw function. These are all functions of the account class. So the question is now, I guess, is how does a.withdraw, how does a.deposit, or how does a.anything work with these functions? And notice like one particular detail here is that we define functions like this. We define methods like this. We say, give it the method name, and then we pass in self, as well as the argument that you care about. So we'll see how that's useful later. I can call these methods or invoke them by following these rules. All methods access the object via the self parameter and manipulate the object's state. Self parameter is used to identify the object. It lets us know that my account is different from Stan's account. So for example, if we look at that same example again, deposit defines two parameters, self and amount. And the ways that we can invoke them is because we know that this is a function of a class, I can either, from the class, access the function directly and pass in the self. Or from the object, pass in self automatically. So as an example, if we say A equals account of Kevin, so this is account for Kevin, A.deposit 100 gives us 100. And we can also use it, access it through the account class as a function. So here we saw earlier, A.deposit 100 is accessing it through the bound method. And this next call we're about to do, account.deposit A, 50, that will be accessing it through the function. And so now if I check for the balance, they both affected the same object. And now I have $150 in my balance in total. So I want to show you a quick demo of this in action again. So if I open up a new tab, I see that I can say A equals account of Kevin. So now I have my account for Kevin. And we saw earlier that I can do stuff like A.deposit 100 bucks. Now I have 100 bucks. And we saw that we could do account.deposit and pass in the account that you want to deposit into and the amount that you want to deposit. So let's go back to the code. We saw that deposit is defined as a function with two arguments, self and amount. So when I look up account.deposit, that gives me the function that takes in two arguments, A and amount. So now my total amount is 150. A.balance, 150. So far, so good. Now I want to show you a little bit about what happens under the hood. Account.deposit, we mentioned, is a function. It's a function. So that means I have to pass it in both self and amount. It's like a regular function. I pass it in everything it needs. But then I wonder what happens when I say A.deposit. Python calls it something different. It's called a method. This is the distinction between method and function I really want you to care about. This is a pretty important distinction, how this works. So Python called account.deposit a function because in the class account, it was defined here. That's why it's a function. I define this function in the class account. But when I make an object, A equals account Kevin, then that object has its own binding for the deposit method. And what this method does is it lets me use this syntax. It passes in self automatically. So I can tell it I just want to deposit right into my account, $10. And it'll accept that. It'll understand what I need. So make sure you understand this distinction. Account.deposit refers to the function. A.deposit refers to the method. I feel like I get way too many questions about this, so I just really want to make this clear. Do you want me to show you, is there any questions? Do you want me to show you anything on the interpreter right now? Would you like to see anything happen? Questions, clarifications, thoughts? Yeah. Great question. What's your name? So Philly's question was, we can access the function, right? We can access account.deposit. We can kind of access this like the same deposit method for the account, right? Using these two different ways. So then can we also do something like, can we also get a.balance from account? And I don't think that's possible with what we've learned so far. There might be like some Python internals that let you do it. But right now we see that if I want to try to access account.balance maybe, then we kind of have a problem of context. Like how does Python know if I mean my account's balance or Stan's account balance, right? So if we try to type that, attribute error, object not found. So I don't think there's a good way that you can give it or tell Python what you mean, except in the case of functions, where Python has this special behavior to make it easier for us. Great question. Yeah. Okay, I made a mistake on the slides. You're probably right. So we can fix it when we get there. Oh, yeah. Maybe I changed the code up a little bit, but forgot to change on the slides. Good point. Yeah, so there's like slight difference in what I did for self.balance, return self.balance. And maybe I messed up here. Great point. All right. So then let's discuss more in detail methods versus functions. Python distinguishes between these two things. I mentioned this earlier, bound methods, which combine a function with its instance. That's why we can say a.deposit refers to the bound method. Functions, which we're familiar with, I can say account.deposit, and that refers to the function. And there's two ways we can invoke it. I can invoke it from the object, which gives me the bound method and passes in self-automatically. So then a.deposit refers to, this is how we'd say it, the bound method of a. And from the class, I can also invoke the function and pass in self explicitly. So account.deposit refers to the function with no association to any particular object. Right? And that kind of makes sense because account refers to the class of all objects. You're not saying this particular object. And we've already seen the demo, so I'm not going to show you again. Any last questions about methods versus functions? There's like plenty of practice problems from past midterms as well. Just like wrap things up, we have all objects have attributes, which are name value pairs. And classes are objects too, so they also have attributes. So we saw earlier, very beginning of this lecture, that we saw that we had the account class, which we drew as a box, and that box itself is also an object. So it's a little mind-bending, is that we have classes themselves are objects. I wouldn't worry too much about that if that statement is confusing, but we make we understand that classes are objects because we draw a box for them. And we can put bindings inside that object. And so we have two different types of attributes that we care about. We have instance attributes, which are the attribute of an instance, and class attributes, which are the attributes of the class of an instance, of the class of an instance. So you have kind of like two spaces here. We have class attributes and functions. And then finally, we just introduced bound methods, which combine these two ideas. We've seen functions in Python for basically the entire class. We just now introduced class attributes. And when we talk about methods, we mean the intersection between those two. Functions are objects, as we mentioned earlier, and bound methods are also objects. But these bound methods are objects that pass in self-automatically. And dot expressions evaluate to bound methods for class attributes that are functions. So essentially just redefining this part. Dot expressions evaluate to class attributes that are functions. Any questions about this terminology? Because like this is something that'll be useful for tomorrow, and I'll also show it again. All right, summary. Object-oriented programming is another way, or what we call a paradigm, to organize and reason about programs. So objects combine two different parts. They have attributes, which tell us what the object is. Like, for example, I have a holder. The account for Kevin has a holder, and it has a balance. And it also combines it with behavior, which tells it what the object can do. You can deposit to Kevin's account. You can withdraw from Kevin's account. And computations result from the interactions between these objects. Like, for example, I can withdraw from some account and then deposit into some other account. And we saw that the Python class statement allows us to create user-defined data types that can be used just like built-in data types. Like we saw last week that you could do list.pop or list.append. And we can do the same with our own classes. We can define our own methods that have that kind of behaviors. And then tomorrow we'll discover how to define the relationships between different classes. So we saw today that we have individual classes like account. We'll see tomorrow that you can make other cool stuff like checking account. I guess that's not really that cool, but then we'll see more fun stuff as well. And then that's it. All right, we'll let you off free a little bit. Cooperate next time.
Actually super long. I think we might need to change it so that the TA will go over most of it, and then the AI will go over study tips and maybe ask them questions about what the TA actually does. There's no way we have enough people to do this.